Hello. In the last video we did lesson 5, number 10, and we talked about given different types of triangles, how do we find the area, and we drew this one at random, triangle DEF, and then we talked about how since it's not right, it's not isosceles, it's not as easy to find the area of. So what I thought I'd do is I'd actually go through the long-winded way of finding the area, because the algebra there is important. So if you watch that last video, you'll see that we calculated this area as 12 units squared. So let's see if I get the same answer. If I don't, maybe I have to go and film that video again, but that's always fun. I learn more along the way. So here we go. So again, when people have a triangle, the first step is to choose your base, and often choosing one length over the other is actually will make it easier to find the area. But what we really want to look for when we're choosing a base is we want to look for horizontal or vertical sides. By doing that, it makes it really easy to find the height of a triangle. Because this triangle doesn't have any horizontal or vertical sides, finding the height is a little more challenging, because I've dotted in, if I chose, let's say, length side E as the base, this would be my height, and it looks like it might actually cross through that nice integer point, but I'm not sure. So what I'm going to do now is I'm going to do the following. I'm going to label some things on this diagram to help us out. And I'm going to change color. I'm going to go good old pink. So I'm going to call this GE. I'm going to call that line. Actually, I'm going to call this line 2. And I'm going to take DF, and I'm going to call DF line 1. So I'm going to kind of go through the following process. I'm going to find line 1 and use it to find line 2. And what I mean by that is, notice, if L2 intersects L1 at 90 degrees, that means their slopes are the negative reciprocal. So that's the first thing I'm going to do. Then what I'm going to do is I'm going to find the point of intersection. So I'm going to figure out where these two lines touch, which I suspect is 0, -3, but that could be just a product of, I just sketched that line and I didn't really think about it too much. 3, and then once I find that point of intersections, I'm going to find the length of, I'm going to find length E, and I'm going to find, and let's call this length from G to E, let's call it length G, and I'm going to find length E and G. And then once I found E and G, I can then pretty easily find the area of that triangle. Okay, let's do this, shall we? So, line 1. So line 1 is the line that passes through DF. So I can see that has a slope of 1. And I can see if I extend this, I don't have to do any algebra actually, it actually is going to have a y-intercept of 1, 2, 3, of -3, so a b of -3. So therefore, we have y is equal to x minus 3. Okay. So now let's find line 2. So line 2 intersects line 1 at 90 degrees, so therefore the slope of line 2 is the negative reciprocal of slope of line 1, so it's -1. And if I take this and I can see, oh, I have these backwards, pardon me, this slope is -1, and this slope is +1. Now I could go and redo this video, but I really want to show a point is that I had made a mistake there, and what allowed me to catch that was I went back and I was actually saying to myself, does it make sense that this slope should be negative? And of course the answer is no. So now that I've fixed that mistake, let's go back and look. So if I follow this line up, I can see it's actually a slope of 1, so I think I'm right. And so we see the point of intersection here is going to be 1, 2, 3 is going to be 3. So b is equal to 3. So therefore, line 2 is y is equal to -x plus 3. So actually now, I could tell you point G. I could tell you that point G is going to be 1, 2, -3, 0. However, just for the sake of this discussion, let's let's find g. So we're going to take y equals x minus 3, and we're going to add it to y equals negative x plus 3. So we're going to get 2x, not 26, 2y is equal to 0, so y is equal to 0. So therefore, if y equals 0, x is equal to negative 3. So now I know that point G is negative 3, 0. There we go. Okay, so now we found the point of intersection. Let's find the length of E and G. So E is equal to the square root of, and let's count, 1, 2, 3, 1, 2, 3. So square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, which is the square root of 18. And again, I'm going to leave it like that. And I see that G is equal to the square root of, see, 1, 2, 3, 4, 1, 2, 3, 4, 4 squared plus 4 squared. So G is the square root of 32. Okay. So if we come down here now, so therefore, we can find the area of this by, it's going to be 1/2 the base times the height. So area is equal to 1/2 the base, which is root 18, times the height, which is root 32. So now I pause for a second, I scratch my head a bit, I say, okay, well, is this 12? I'm not sure. So you could take this and plug this in your calculator, or if you're familiar with rewriting these radicals as mixed numbers, that's one way to do it. So I'm going to do that just to show you. What I do is I take 18 and I break it up into two numbers, one of which is a perfect square, in this case 9 times 2. Then I take 32 and I do the same thing, so that's going to be 16 times 2. So what this allows me then to do is say 1/2, and the square root of 9 is 3 times root 2, times the square root of 16 is 4 times root 2. So the area is equal to 1/2, 3 times 4 is 12, root 2 times root 2 is 2, so therefore the area is 12 units squared. And look at that. I am correct. So again, this is really long. There's a lot here. There's a lot of really interesting ideas here to understand. But again, it's about multiple ways to approach the same problem. So what I did, just to recap, a really big takeaway from this one is that often what happens is we need to find the height of a triangle to find its area. And the temptation then is to find the midpoint and then go from the vertex to the midpoint, but that's not always the case. That's only true with isosceles triangles or equilateral triangles. In this case, we need to find the shortest distance from the vertex to the line segment. So we go on the diagram, we label these line 1 and line 2, and we find the equations of line 1, and then we use the equation of line 1 to find the equation of line 2, and then we find the point of intersection, which in this diagram actually we could pick out. And then we find the length of the base and the height, and then we simply plug it into our area formula. A final thought is, again, these are called radicals, and we could plug these into our calculator, but there's a nice technique called changing a radical to a mixed number. Sorry, a mixed radical, pardon me. And what we do to do that is we take whatever's under the radical sign, the root sign, and we try and write it as a perfect square times something. So in this case, 18 can be written as 9 times 2. And the reason this is nice is because we can take the square root of 9 to get 3, and then we just leave the 2 under the square root sign. The square root of 16 is 4, and we leave the 2 under the root sign. So therefore, then we expand this. So 3 times 4 is 12. Root 2 times root 2 is 2. The square roots cancel each other out. And then we cancel out the 2's, and we get 12 units squared. I hope this video helped.